What is going on, Alex Bros? It's Mr. C here, and in this video, I'm going to talk about the continuous interest formula, as well as do an example involving it. So we've seen a couple of videos on how compound interest works, in particular, the effect that it has versus simple interest, as well as a formula that we can use to figure out the amount of a deposit, loan, or investment after T years have gone by under some other conditions, namely the rate and number of times that interest is compounded throughout each year, and so on and so forth. So with the compound interest formula, n is typically a fixed value. And as it turns out, when you increase the value of n, you get a little bit more money at the end of the term of the loan. But it doesn't mean that you get an infinite amount of money. For example, if you were to take n and allow it to go to infinity, so I like to say that this is a situation where interest is being compounded at all moments of time, there actually tends to be a limiting value. So, for a while, when n increases, we can see the amount at the end of the term of the loan or investment increasing, but it doesn't increase to infinity, so there's a limiting amount. So what happens if we allow n to go to infinity is we get a situation called continuous interest, in which case interest is being compounded at all moments of time, or in other words, continuously. And what it does to the formula for compound interest is that it morphs it a little bit. Specifically, this part of the formula 1 plus r over n to the power of n, gets replaced by e to the power of r. And we end up getting what's often referred to as the PERT formula. A, which is the final amount, is equal to P, your principal, times E, so the 2.718-ish number. And in the power of E, we have the product of the rate times time. So what's interesting about this formula is that we know that E is a fixed value. All we would need to figure out under the conditions of continuous interest, all we would need to know after time t has gone by is the amount we're starting out with, the rate, and how many years the loan or deposit or investment is going to be active for. So this leads us to our first example involving this formula. It says determine the balance of a $3,500 investment at 7% APR compounded continuously. So when you see this key word involved in the instructions, you should put the formula for continuous interest at the forefront of your mind. Now I'd like to go ahead and make a little list of information that we have based on this statement here. We don't know the value of A, but we do know that there's an initial amount, and that's $3,500. So that's how much this person is walking into the investment firm with. We have a rate of 7%, and of course you want to use 0.07 instead of 7. We don't need n because we know that n is going to infinity, but we do need the time t, which is 8. And so we'll go ahead and plug all this into the formula. A equals p e to the rt, and so that's 3,500 times e to the 0.07 times 8. Now what I would do next is maybe go ahead and multiply those two values out. So you get 3,500 e to the power of 0.56. And then of course we'll type this into our graphing calculator to get an approximate and more practical answer. So 3,500, and then second ln, and in the power is going to go 0.56. So after 8 years have gone by with an APR of 7% and interest being compounded continuously, this person is looking at some growth, almost double the amount, we're looking at $6,127.35. So all that extra money was earned by just waiting some time out. So our final answer here is about $6,127.35. And that's for the pain and torture. Fun and excitement for this video ends. Of course, if you have any questions, let me know. Otherwise, I'll see you in the next one. Thanks for watching.